Whose life would be better if you knew more C++? Whose life would be better if your coworkers knew more C++? Let's get started.
All right, hello everyone in here, out there. I'm Arthur O'Dwyer. I've been the chair of the Back to Basics track in previous years. This coming year, actually, we'll have a new chair, which will be Klaus Igelberger, who is also speaking in the track this year. That's going to be great. But since he's in Germany, Amir asked me to just say a few opening words here. And so I'll welcome everyone to the Back to Basics track. This is our track opening keynote. We will also have a closing keynote by Marshall Clow on Friday, and in between everything marked Back to Basics is at this Back to Basics track. Our mission statement here is top trainers explain all the fundamentals, so all the essentials. So that's what you'll get out of this track. I hope whether you're new to C++ or you're revisiting something that you already kind of know, brushing up on something, it's going to be great. I think we have a really high quality lineup this year. And of course, feel free to mix and match between the Back to Basics track and the rest of the program. As most of you giving me quizzical looks are like, what? Yes, you already are mixing and matching, so excellent. Anyway, I think that is all. If you have any suggestions, comments, feedback on how to improve the Back to Basics track in future years, please send feedback to b2b_track@cppcon.org. And with that, I'll turn it back over to Amir. Take it away.
Thank you very much. And thank you all for being here today for this talk. So we are going to talk about understanding and mastering C++ complexity, which is a complex subject. So before we begin, and it might be that you look at this slide and you are a bit disturbed, because begin is not a function that should have side effects, and here we would have some discussion on the begin. So, and it's not Boolean or anyhow, this is just a slide and a title. Before we begin, a small question. The question, the quiz is open first and foremost for those of you who have 0 to 3 years of C++ experience. I just checked before we began that we have those of you in the audience. So please play fair. What in this code below would compile, and if something doesn't compile, why? So you see a few lines of C++ code here, quite simple, I would say. We are creating 2 strings and try to swap them. We are creating 2 integers and try to swap them. Does the code compile? If so, how? And if not, why? Any answer? 0 to 3. Okay. Any suggestion? We would go up with, yeah, please. Swap is not defined, you say. Swap is not visible to the compiler. For both? For both cases? For only one of them? For both. Anyone thinks otherwise? Maybe swap is being visible to the compiler for one of them? If so, how come? Yeah, I did ask, and we do have some. So this is why I still keep it for this level of experience. So I think we'll go up. So you do want to take it. Swap is infected by those include. Swap comes from include utility. This is why we have utility over there. So the question here, again, for those online, it might be that I got some note over there, it might get away. Does the code compile? If not, why? And if it is, how? So I would just, in a way, point you at the question. We do not use any namespace here. There is no using std or using std : std swap. So how come swap is being, like said before, visible to the compiler? And I would tell you that swap is being visible to the compiler for one of the cases. Which one of them? You can go on if you want. So you say for the integer case, swap would be visible. No, in fact, any other. I would open it for anyone. So yeah, you can go on. Anyone wants to take the question? Nimrod, I know some of the guys here. Yeah, but you have to explain. I only left one option, and the option is that for integers, it would not compile, and for the strings, it would compile. And the question is why? Because I'm using std string, and std string does find swap. And the reason is, well, maybe you need some motivation. I have a shirt as a prize for those who want to answer. This is it's from a conference that I'm a co-organizer of. It's from 2019, and the back of the shirt says "Language Lawyer since C++ 98." Yeah. So anybody wants this shirt? Well, I'm looking for 3 letters abbreviation, 3 letters acronym, starting with A. It was called Koenig lookup. Now usually using 3 letters. Well, it seems that nobody takes the shirt. Maybe someone wants ADL. Argument-dependent lookup. Once you have one of the arguments coming from std, then the function is being looked at also in std. So since std string is being visible to the compiler here, and then swap of 2 strings being looked at std, at the standard library, while for 2 integers, it does not. Sorry, I keep the shirt. This is a bit complex, even though when you know that, you're fine. And the question is, does it make, in a way, our life really complex? And I would say no, not, because eventually either you get compilation error and you solve it, or you use the proper using namespace or using std swap. So it is solvable in a very easy way. And still there is some knowledge over there. Okay, complexity. What this talk is about and what it's not. It's not about algorithmic complexity, no big O on this talk, even though we would discuss big O in another talk that I'm giving with Adam, who is right here, my co-speaker on Friday, talking about algorithmic complexity. All different, term of complexity. Complexity is a very broad definition for this talk, so I'm going to talk about anything that makes it hard for you to use C++ or to understand it, including things that irritate you or annoy you, waste your time, things that you perceive as being bug-prone or broken in the language, or things that you see in other languages and you say, but I can do it in D or any other language. So what irritates you or what you perceive as being complex? And a few words about myself. I'm a lecturer at the Academic College of Tel Aviv-Yafo and Tel Aviv University in Israel. I'm also developer advocate at Incredibuild. We do build acceleration based on parallelism, on parallelizing to on-prem idle machines or on the cloud. And I'm also the co-organizer of the core CPP conference. The origins of the talk. A graduate student of mine was interviewed for a C++ position. She consulted with me whether she should go to whether C++ is the right choice. And well, you can understand that I'm not totally objective about this question. So I convinced her that C++ is a good choice. And she is now a C++ developer at waves.com. And we created together this talk about why C++ is a good choice, or do we still have complexities in C++ and how to look at them. And the talk is on YouTube. You can enjoy it. It's in Hebrew. So we will give it now in English. Complexity. Isn't it the name of the game of being a programmer? I mean, we are paid for that. If it was not complex, I don't know, maybe we would go for other occupation. There is a post by, do you know this guy, Joel Spolsky? He was very known about having a very good blog post, but now he's being very known of being the one of those who created Stack Overflow. So he's the man behind Stack Overflow. And he had a post on 2005 talking about those schools, those institutions who no longer teach C and C++. Go with first year Java, or today it's quite, many schools go with Python. By the way, I teach C++. I believe C++ is important. But the reasons George Spolsky put for you should teach C++ is because, in a way, it is complicated. So it would make your students better. Now, well, it's an argument, but I would not say that you should teach something because it's complicated. You should teach it because it's useful. So I would not go with this argument. He's talking about today students go with Java or Python, and then he come and say, oh, you lazy guys, I was with C and C++. And then comes someone a bit older and says, C and C++, you lucky guy. I was with zeros and one. And then come another one says, you lucky bastard. I had only zeros. So yeah, the question is whether complication is something of, of any value by itself. No, I don't think so. Is C++ complex? Why is it? Can it be less complex? Well, I want to ask you, what makes C++ complex for you? And please check in the questionnaire that you are going to get in a moment, only the things that bother you in person, not things that you heard about but didn't touch. If it's something that you wanted to learn but eventually seems a bit hard, yeah, you can check it. But if it's something that you just heard about it and didn't have time to go to, so yeah, put it aside. So this is a QR code, and there is a questionnaire. We'll put 1 or 2 minutes in that. You can see it also back at home online. Please scan the QR, go to the questionnaire. You would see there a list of options. The list is very long. There are many candidates. You can check as many as you like. It's okay also not to check anything. There is one option saying that C++ is a breeze for me. This is also fine. And there are 2 questions in the questionnaire, only 2 questions. What is complex for you? In the way, as said before, complex like hard to get, hard to use, annoy me in a way, waste my time, perceived as bug prone, or can be done in a better way. Maybe you know it from another language who proposed something similar but easier. I see people fill the questionnaire right now, right? It means that the QR is good. Yeah. Yeah, I will give you one more minute. The list is long. There isn't any option to just select all. You have to manually select what you want to select. But I don't think that it's very subjective. Someone finds something, another one would select other things. Okay, let's take a quick look at what you see as complex in C++. So I'm going to the questionnaire results, and this is what you selected. Many of you, let's check, the higher bar, the one with 32 answers, 33. Forwarding reference. Many of you see forwarding. Our value in move semantics. Yeah, our value in move semantics is very high. Is very high, and keeps going up. Howard Inant, we need your help here. Howard Inant is the man behind our value in move semantics, a very important addition to C++. But yeah, teaching that, being a teacher, I know that this is something a bit hard, but it has value. Let's see if we have other interesting stuff. Pointers and reference are there. Quite surprising for me, but again, it's there. Sphine. So yeah, we have a list, and I would not dive into the list, but I would go through some additional code stuff that we would take a look together. But before that, I want to ask why programming is complex to begin with. It's not only C++, it's programming, in general. What makes programming complex? Well, the main reason that programming is complex is because we are, in a way, trying to take something which is a bit fuzzy, like human requirements, and take it to something which is very clear, very mathematical, which is either true or false. And this shift from something a bit fuzzy makes programming complex. Now, it is being said that sometime there would not be any programmers because you would just write requirements and, some very sophisticated software would take these requirements and create the program for you. And I say that then those who would write requirements would be programmers, because there would be some kind of software language. I think there are such languages out there already. And writing requirements would become like writing code. Now, this fuzzy logic I would say that would keep two occupations as the last occupations, while all the others would go off. Robots would be around. Two occupations that are dealing with fuzzy logics are programmers and lawyers, which keep jobs for programmers, lawyers, and for language lawyers. What makes software language complex? So if we take it into the syntax itself, writing programs, too many ways for doing same thing. If we come to a language and there are too many ways for doing the same thing, this makes the language a bit complex. Too few ways for doing things. Yeah, it's also a problem. Suppose I want to do something and it's hard to express myself. I can do that, but in a very cumbersome way. Lack of standard documentation or proper examples, lack of community, complex model, like too low level or too high level, too abstract, contradicting paradigms, rules that are not intuitive, complex problems, new syntax that come along all the time, backward compatibility issues, and lack of proper tools. This list, in a way, is many factors, many issues that may affect a language, may make a language not usable or hard to use. And the question is, if we look at that and we ask ourselves, well, what about C++ regarding this list? So let's go back. Let's ask ourselves, if we are talking about C++, and this is the list, okay? And I will remind you that the talk began with a conversation that I had with Amit, my student. And I did persuade her to go and fetch the C++ job. So in a way, this is a conversation. At the end, I'm making the argument. So if I say that something is not complex in C++, this is my view, and you have to take it. So too many ways for doing the same thing, or too few ways? No, I don't think so. I think that even Python that has the Zen of Python, saying that in Python there is one good way of doing something, well, that's not true. Even in Python, we have several, I would say, dozen ways of doing the same things, and this is only with list comprehension, and then you have some more with other ways. So even in Python, we have many ways, and in C++, yes, you have more than one way, but usually it's not a real issue. Do you have few ways? Too few ways? No. So I think this is not a problem of C++. This is my view. Lack of standard documentation or poor examples of community? No, for sure. This is not the problem of C++. Complex model? Yeah. In a way, C++ is dealing with low level. And in a way, C++ do have high level abstractions and some contradicting paradigms and some rules that might be not so intuitive. So I would keep it. Maybe I would just rephrase that, because too few is judgmental. I prefer to say has quite few low level, has quite few high level features, and some rules which are not so intuitive. Complex problems. Well, it's not a problem of the language, because yeah, it deals frequently with complex problems, but eventually, because the language allows that. So I'm not sure that I would keep this one as a problem with the language. New syntax and new stuff that getting into the language. Yeah, people are a bit, annoyed by, yeah, I have to learn new things. But I just convinced you, or I just, decided for you that no, C++ doesn't have too many ways of doing the same thing. So if I have something new in the standard, yeah, it's good. I needed that. So I think that new syntax is not something that I want to keep in the list for C++. Yeah, you have to learn new things, but it's a virtue. It's a good thing. The language is evolving, coming with new approaches. Backward compatibility, no, this is not an issue for C++. It is an issue. Even Python, that all of us love, I don't know, many people love Python. It's a good language. From Python 2 to Python 3, you had to rewrite many of your code. C++ do keep for decades compatibility. So no, this is not a problem for C++. Lack of proper tools. Yes, there is some problem for tools in C++, but it is improving. It is improving. So if I take a look at this list, I would just want to take away all those that, it's not a real problem. And then we are left with a few issues that I want to discuss. I want also to take off the deals frequently with complex problems, because again, it's not the problem of language. Yeah, it allows you to do complex stuff. And then we are left with complex model. Now, as quite a few low-level features and few high-level features, again, you don't have to use it. If you don't need to write bitwise operations, don't use bitwise. If you don't need a pointer to a member, so don't use pointer to a member. You don't want to use concepts, that's fine. You can either use concepts that are part of the language without creating your own concepts. So I would say that the first two bullets there, yeah, we have low-level features and high-level features. We can use them if we need, but it's not something bad about the language. So we're left with these two. Yeah, C++ has some contradicting paradigms or rules, and some rules which are not intuitive. And that's what you hold against a language with more than 5 million programmers and billions lines of code? This is the problem? Well, it's not. There is no silver bullet. A paper by Fred Brooks, 1986. Back then, many years ago, he wrote that in a decade from now, 1986, there would not be any paradigm methodology that would have significant order of improvement in implementing code, in software programming. And there were things that came on since 1986, which is the biggest one, the internet. And yet, I think, it's not that I think, many people agree that, yeah, there isn't any significant improvement in the way, there isn't any silver bullet. By the way, this picture is taken from a panel discussing the paper, discussing that there is no silver bullet in Uppsala 2005. It is Martin Fowler dressed as a werewolf. They tried to shoot him at the end, and they didn't have a silver bullet. And Fred Brooks himself in the middle. And the paper discussed why isn't there any silver bullet? Because it's a question of essence and accident. When you want to write something, you invest in the essence. And all the rest is an accident. And the accident, what Fred Brooks says, is the accident is the small thing. The accident is the things that you can improve. You can come with a better tool. But you would deal only with the accident part, not with the essence part. And the essence is the ambiguity in requirements. The essence is the real life, is writing complicated code, not the accident. So we are going to play a little game called Essence or Accident. Are you ready? Let's play. And we're going to see some C++ code. This one, is it an essence or accident? We want to find the prices of a certain stock. We have a stock symbol. We call it ID. So there is a map of stocks which associate the symbol of the stock to a list of prices. And the list of prices is, in fact, a list of pairs of a date and the price on this date. Like, for example, the closing price for this day. Essence or accident? So you can say, what is the accident you are asking about? Well, this complex code, this complicated line. Well, yeah, I would say it's a bit of an accident, but it is improved in C++ 11. You should just write auto quotes ITR equals stock find. And by the way, C++ came up with auto before Java and C# came with var. It was before. Coming with, you know what? The compiler can deduce the type for you. I would say we have here something quite useful. Well, it was an accident, but no casualties, I believe. Essence or accident? What do you say? What is the accident that I'm asking about here? Well, there is a problem in the code here. What is the problem? Or at least, might be a problem. When we are teaching polymorphism, we usually say that if you have a polymorphic hierarchy, you should have a virtual destructor. And this class doesn't have a virtual destructor, which means that if I allocate a shape, which would not be a shape, it would be any, derived type, and then I dismiss it, I delete it without the proper type, I just delete the shape. The compiler doesn't know what is the actual shape, and we did not reach the proper destructor. And the question is, can the compiler deduce the class that the class needs the virtual destructor and provide one? So maybe this is an accident. Maybe. In other languages, you do not have to think about destructors. Well, you do not have RAII. But maybe the compiler could have create a destructor for me. What do you say? So the problem is that the question is, what are the actual rules for you must have a virtual destructor? Because if there is a rule, then the compiler can go with this rule. But the question is, can I know that the user, that the programmer actually needed a virtual destructor? Well, let's take a look at this code. We have a shape, okay, and we create a rectangle. And in this case, is there an actual need in the code that you see now for a virtual destructor? Yeah, rectangle. The question here was whether rectangle is a type of shape. In my reality, it is, and also in this part of code. Yeah, rectangle is a shape, which means rectangle derives publicly from shape. So we have a rectangle, we create a rectangle, and then we point to the rectangle with a shape pointer. And then we call draw, and that's it. Main is done. Do we need here a virtual destructor? And the answer is no. There isn't any need for, because we do not allocate any memory. And you cannot tell that by looking at the class itself. It depends on the actual use. And C++ has a very simple attribute that Bjarne just talked about. Don't pay for what you do not need. You need something, ask for it. You do not need it, you would not get it if you are not asking for it, because it's costly. So yeah, it's not an accident. It's an attribute of the language. You do not want to pay for something that might be that you would not need. Essence or accident? Well, this is something that I teach. At a certain point in the course, we have a cache as an example of some complicated template class. And in fact, in this one, I want also to teach type and non-type template argument. So I have a cache which is based on the key type and the value type, and the cache has size, which is a non-type template argument. And we have also a fetch function. So if you do not have the actual value that you look for in the cache, then I can go and fetch the thing for you. Okay, so we have also a fetch function. And inside the cache, I have a nested class holder, and the holder holds the actual values that are kept in the cache. Now, the cache is a least recently used cache, which means that those, if the size is exhausted, I just drop those which were least recently used. And in order to do that quickly, I have in the cache itself, you do not see it currently in the code, it's in the 3 dots part. I have in the cache a list, a sorted list of all keys sorted by when it was fetched, when it was asked for retrieval. So the first one is the one that somebody asked to retrieve. The last one is the one for being dropped, if size is going to be exhausted. And inside each one, I want, if you are going to retrieve me, I just want to replace your position in the list. And I don't want to look for you in the list. So inside each holder, I hold the actual position that you have in the list. And I hold it with a list k iterator pausing list. So this is where I'm in the least recently used list. So in case you fetch me, I can just go to the list, delete myself from there, and put myself at the front of the list. What is the accident here after all this talk? What bothers me? When I teach that, there is something that I didn't teach yet in class, which is the type name keyword there. And then students ask, what is the type name there? And the answer is, well, in fact, the compiler in some cases requires you to say the type name word. And then the students ask, okay, and what are the rules? When should you add the type name word? And I'm telling them, well, it's quite easy. Usually what I do, I don't put the type name word. And then when the compiler asks me to, I just add it. So it's quite easy. But C++20 actually solved it, because in C++20, most of the places where you had to put type them are not required anymore. So yeah, in a way, it was an accident in a way, because you look at it and you say, compiler, we're smarter, you and I, you or I. You can tell that this is a type, and yeah, you can tell. By the way, there are many things in the language that at a certain point, you are convinced, or somebody convinces you that this is how it works. It cannot work otherwise. Like, for example, in C++ 98, you couldn't initialize a data member. And the reason given was that, it doesn't have a place in memory yet. Well, it's a bogus reason, because yeah, it doesn't have yet a place in memory, but the compiler is smart. The compiler can create code which says, when it will have a place in memory, when an object is created, please initialize. And you know what? In C++11, you can do that. So the bogus reason was gone. And here again, the type name, there was a reason why type name is required, but then it was solved. Essence or accident? Well, the thing here works as this. We have in main an array, a simple static array, 1, 2, 3, and the others. And we want to have a container of unique values. So unique values should all the unique values from the array at the beginning of the main. So we create a set. And because there is CTAD, class template argument deduction, the compiler can deduce what is the actual type of your set. So in C++17, it's okay, in some cases, to omit the actual type of the container. Because, you have a constructor. You can take a look at the constructor, and if the arguments in the constructor can explain what I'm trying to build here, so in some cases, CTAD, compiler, constructor template argument deduction. And I'm using that here. So I'm creating a set of values, and I'm giving it the beginning of the array and the end of the array. And I'm looping over the array. What is the problem here? Well, the problem here is that it would not create array of integers. It would create a set of integers. It would create a set of 2 iterators, the first iterator and the second. And if you change the curly brackets to circle brackets, then you are fine. And this, by the way, was raised in a meetup, and then it went to the Twitter, and a lot of discussion about, this is a problem. Well, and then came Barry and said, well, you know what? It's the same problem we are talking about, that, initialization in C++ is a bit problematic. Yeah, we did something a bit problematic with uniform initialization. Yeah, we know that. It's the thing. It's not something new. It's the thing that we talk about. Yes. Is it an essence? No. It's a small accident. Why do I say it's a small accident? You have to know that there is a difference between curly brackets and equal, or circle brackets. And once you know that, yes, it's a bit of an accident. It's a bit of, like I said in the list, paradigms which are not coherent. Yeah. But there isn't any language which is perfect. Essence or accident. How to store a value obtained from a vector. Should I just pop back? That when you want to obtain something from the vector and delete it, like I want to pop back the last one and drop it from the vector. I have to call back to get it, and then pop back to delete that. Is it the right code? No, it is not. Why? Because it's not the most efficient way to do that. What is a better way to do that? Well, in fact, you can move it when you take it from the vector. Essence or accident? Well, it is an essence because, yeah, before C++11, this is how you would do that. But you have now a better way. You can use the better way for better efficiency. You can move away from the vector, like steal from the vector. And then, by the way, for a slight moment, you have an invalidated item in the vector. Nobody is allowed to go there, but I know it's not a multi-threaded program here. Otherwise, there are other issues that you have to handle. Maybe you are locking. But yeah, the item there is invalidated, but I'm going to delete it anyhow. I'm going to pop back it, so it's fine. And suppose that I have issues with R value and move semantics. So you know what? Go back. It will work. It would not be the most efficient way to write that, but yeah, it's better to do that one. Essence or accident. We have a vector Booleans. We want to toggle all Booleans, change their values, flip them. Those who are true should become false and vice versa. Well, there is a problem with this code. It would not compile. How come? Because when you loop over vector of Booleans, you get bit reference, which is a temporary object, right? And this is how you should do that. Well, I would say that vector of Booleans is an accident. But forwarding reference is an essence. And using forwarding reference is something that you have to know. You have to use in certain places, not only when you loop over vector of Booleans. Vector of Booleans is a beast. It's something that you have either to avoid or know what is behind that, okay? But if you do that with forwarding reference, it would work for both vector of Booleans or vector of integers or vector of strings or any other. So yeah, and again, yeah, vector of Booleans is an accident in a way. Essence or accident. We have two structs here, A and B. B derives from A. Both have a foo function. Foo of A returns 7, foo of B returns 8. And if I call, it's not the same foo. It's not overriding. It's not overloading. It's just, you know, it's hiding. It's foo of A gets an int, foo of B gets float, and then I call boo with an int. Would I go to A or B? Now, most people, even veterans in C++, don't know the answer. Or it takes time till they say, you know, yeah, the rules of hiding means that you would go to B. And the reason they usually we do not recall what actually happens here is because we do not write this code. So in many cases, we look at something and we say, oh, this is very complicated. Well, don't write it. And then you are away from this complication. This is a very simple solution. So don't do that. The rule is that if there is a function that is in your type, in B, is ready for you, you can go there. It's hiding even the more exact signature, as long as it is being, and even if it is not, then you would get a compilation error because you are hiding the foo of A with the foo of B. And there is a reason why the language decided to go this way. There is a good reason. If you read about that, it's a good decision. But I would say the better approach would be not to do that. I would have to go over, and then if there are questions, maybe at the end, or I would be here when we finish. Okay, essence or accident? Well, sphinx. Sphinx is an accident. Is the same kind of accidents like that creates traffic jam on the other side. Those that you cannot keep your eyes from this accident, right? But it's a good tool being replaced in C++20 with concepts. So it's a good tool, but very complicated. Let's drop it. Let's bring something more powerful, and concepts is going to replace sphinx. Essence or accident? Well, we have chaining. And the problem with the chaining that we have here is that it doesn't work till C++17. And I would not dive into it, but when you call replace, the calls to replace in the chaining would go in order. The calls to find inside were not required by the language to be in order till C++17. So it was kind of an accident, but it was solved in C++17, saying that, you may write bug-prone code even in actual books. This example appears in books before C++17 of something like you can do that without saying, no, do not do that. In C++17, it is doable, and the order is guaranteed. And it is useful because the pipe syntax that comes with ranges is using chaining a lot. The principles that bring us here were discussed by Bjarne just this morning. And the funny thing is that I love the talks by Bjarne, but they mostly resemble each other. You hear him once, and the next time, it's wonderful to hear him again. But you hear him at 1994, he's talking about almost the same things. And what was changing is the language, which is quite fascinating. He's talking about something, and then 2 or 3 decades over, you see it in the language. And when Bjarne is talking about don't pay for what you are not using, this is things that we see as an essence. The acronyms, we had some acronyms at the beginning, right? How can we manage all these acronyms? Well, it's quite easy. Go for Arthur O'Dwyer blog. He has all these. I would not go through them. Or join Bob Stiegel's lecture at Back to Basics on Friday. You would go through these, or go to It's Complicated by Kate Gregory. You can, the pyramid of C+ knowledge. Nobody took the language lawyer shirt, but it's okay. It's okay because in order to be an applicative C++ developer, you do not need to know it all. So there is some kind of pyramid. And in some cases, we think that we know too little. It's fine as long as you have the bare minimum. So what is the bare minimum? Well, the bare minimum is not so, well, it's quite a lot. Well, let's keep some of it out. So I think that we can drop multiple inheritance. Suppose that you need multiple inheritance, take a day off the same day and give it to somebody else in the team. Virtual inheritance. When did you use virtual inheritance lastly? Avoid that. Variadic templates is useful. But again, it's not the first thing that you have to know in order to be a C++ programmer. I see some that disagree. Anyhow, I would say that in order to be a good C++ programmer, yeah, the list is long, but you have to narrow it. But you have to read code. You have to be able to read code, and you have to be able to browse CPP reference and Stack Overflow. Being able to read is important, even crucial. You have to know what you know, and when you see something in the code that you do not know, don't assume anything in C++. Go and learn that, or ask somebody. Because usually if you assume that something, my intuition says that this probably does, no intuition here. You don't know that? Go learn it. If you are interviewing for a C+ junior position, make sure that she knows the bare minimum, or you're ready to train. Loves programming, really loves programming, because in C++, if they do not really love programming, you would find themselves in doing product management in a year. So you don't want that. And smart and get things done. This is also from Joel Spolsky. There is a book. He's a smart guy, Joel Spolsky. He wrote a blog, a post blog, and then it was such a success, so he made a book of it. Implications of innocent ignorance. Suppose that, well, my code is less elegant because I don't know so much C++, or it's a bit less generic than it could be. Or, I have some bugs, or it is bug prone. So if I look at this list, well, I can live with some of that. Who is writing elegant code? Are you writing elegant code? It's too overrated. It works, right? It's fine. But if your code is bug prone, we have a problem. So you should strive to be, at the higher part. And if you are in the inefficient code, yeah, you should improve. But less elegant, well, it's fine. I would improve in the next cycle, or the one after, or never. Improving your C++ level. Well, a few notes about that. Curiosity. Curiosity is important. Read, listen, watch. Read QA in Stack Overflow. Ask questions in Stack Overflow. And even more important, answer in Stack Overflow. I like answering questions in Stack Overflow. I do that because I learn by that. I think that I know something, and then I'm coming to answer, and then I understand that I actually do not know that while answering. Like, for example, this is a real case. I just saw a question about Chrono. It was about a year ago, a year and a half. And I look at the question and I said, yeah, I can answer that. I know what to say, and you know, it's kind of a hobby. Takes some time, but you learn things by answering. The best way to learn. So I just wrote something, some code. Now, the community is very accepting. Once you write something, you would get, you know, good feedback. So the feedback that I got is, this answer would be better if you explain why. Now, the thing with Stack Overflow is that once you, you know, try to answer something, somebody else would just, you know, post this thing before. So you have to be quick in order to, yeah, I have a code working, otherwise someone else would just post his code and my code is going away. So I just posted the code, wait a moment. There would come an explanation. No, I want the explanation now. Okay, there would come now. But I was starting to write my explanation about the code, and then our Dinant, the man behind Chrono, just wrote on the same page, by the way, if you ask questions in Stack Overflow about R-value and move semantics or Chrono, the man who would most usually answer you is our Dinant, the man behind these features. It's great. So we have on the same page comments by our Dinant. What is the first error you get on the question itself? Okay, our Dinant is on the page. I'm a bit cold feet. So I answer Astros with wings. Well, I would try to add an explanation, but having now our Dinant on the page makes me a bit cold feet. At least if I'm wrong, I'll have someone to watch over. And I add an explanation. And I get a comment by our Dinant. Oh, you're doing fine. But can you rewrite it without using count? Well, he's right. Count is something that usually you do not want to use with Chrono. It gives you the actual count, but without the measurement units. So you want to do all the math of Chrono, keeping the measurement units. Yeah, well, thank you. So I add explanations and I amend my answer, and our is back. Much better. That was my upvote, by the way. Now you just need to clean up your explanation a little. So I got a private lesson by our Dinant on Chrono by answering someone on a Chrono question, which I thought I know how to answer. That's cool. This is how you learn C++. This is what I tell my students. So improving your C++ level, remember, it's a never-ending mission. And that's it for this talk. I'm here for, I think, 1 or 2 questions if you have. I will repeat the question. So if you have any question about teaching C++, C++ complexity, please go ahead. Yeah, please. Well, there are 2 courses. The question was, at what level do you teach C++? There are 2 courses I teach C++ both in 2 institutions. In one, this is a 2nd year course, which is their first object-oriented programming language, and they learned C before. So there, C and C++, which is quite rare today. In most institutions, the first language is either Java or Python, in some maybe JavaScript. So in one, it's C, and then I teach C++ at the 2nd year. In another is a 3rd year course, which is elective course. So they do not have to learn C++, but many do come to learn C++. They learn C as a mandatory course, and their first language is Python. So the question was, what 3rd year students learn in a C++ course? Well, in the 3rd year course, they come after they already know object-oriented. They come after they already implemented complicated projects. And then we teach them all that it has in C++ through multi-threading and smart pointers. And the project that we had recently was to implement a navigation system. So it is also algorithmics and BFS and DFS and things like that, and how to manage data structures in order to find a certain location in map or paths on the network, etc. Thank you.
You said that you don't need to know like multiple inheritance at first, but I find like for a medium, even for a medium-sized system, you usually do multiple inheritance from very small and simple concepts, and they don't clash. It's usually like the idea that multiple inheritance bring in a lot of issues, but usually it is printable. It is a singleton. It is things that are so distinct. Usually, it doesn't cause any issues. So I don't find right. Do you see a reason to say to people don't use multiple inheritance?
So the question was, I'm repeating the question. The question was regarding multiple inheritance. I put it in the list of, it's okay if it is not the first thing that you know about C++. I mean, it's okay if you go for a C++ position without, or you just heard that there is multiple inheritance, but I don't know, you didn't practice that. And the question was, but in C++, multiple inheritance is our tool to implement interfaces. If you are, it's not for inheriting data members. It's for the contract for an interface. Like I'm sortable and I'm also comparable. I don't know. Okay. Well, yeah, I do agree that for this part, for interfaces, multiple inheritance is usable. But again, it's okay if it is not the first thing. Like for example, in the second year course, I used to teach multiple inheritance, and I now put it as a not required part of the course. I mean, they get the slides. There might be a bonus question in the exam. Usually they do try to learn that by themselves in order to get the bonus. But again, it's a matter of where do you start? How do you narrow it? Because there is a lot to learn. I'm not sure that we have time for another question, so I'm here if anybody wants to talk about teaching C++, I don't know, anything on that. And the first one that would come for a question would get this shared because, you know, it's for you. So the language lawyer, here, I'm here. Here is I think the lucky winner, yeah. Language lawyer.